Hello everyone, my name is Mithal Anil Chopade, roll number EDA 15, batch EDA 1. Today I am going to present the topic optimization of loss function and best fit line using gradient descent. This topic is an important part of linear regression which is widely used in data analytics, machine learning, finance, healthcare, marketing and many more fields. Next, in this presentation, I will explain what is best fit line, the regression equation, what is loss or cost function, and what is gradient descent, and how gradient descent help us find the best line. Next slide. What is linear regression? In linear regression is a technique used to find a relationship between two things. For example, if study hours increase, exam marks also increase. If advertising spending increases, product sales increases. And here, one thing affects the other. This is called correlation. Like we express this relationship with the equation y equal to mx plus c, where symbol y is meaning given as output we want to predict, and x is for input value. Then next is m. M is for slope, that a rate of change, and c is for intercept, where y value when x equal to 0. This formula draws a straight line that best represent the data trend. Then in next slide, what is the best fit line? In this, when we plot data on a graph, the points are usually scattered. There can be many lines, but only one is closest to most of the points. That line is called the best fit line. Here we can see in diagram, it shows the average trend of the data. Slide, we see how do we know which line fits best. Then here we calculate how long each line is using error values, and error equal to vertical distance between the data point and the line. In this, not all lines fit well. We need to measure how long a line is. For each data point, we find the vertical difference between the actual point and the line. This difference is called error. And to measure total error for all point, we use one formula that we can see in next slide. In our next slide is what is a loss cost function. To measure total error for all point, we use formula. Here I am giving formula MAC equal to 1 by n sigma y actual. I is known as actual, and y dash I is for y predicted. Then here n is also given. N is mentioned as number of data points, and y actual the real value from the data, and y predicted the value predicted by our line. Then in this slide, our goal like minimize the loss. We want the best values of M and C that make MAC minimum. If we draw the error values for different M and C, it looks like a bowl shape, where highest points on the bowl equal to large error and lowest point at the bottom equal to minimum error. So our aim is to reach the lowest point. In our this slide, we see how to find the lowest point. In this, instead of trying random values of M and C, we use a smart method called gradient descent to reach the lowest point faster. In this method, we see for in this slide, we see gradient descent concept, main concept. Like, gradient descent is a smart method used to reduce the loss step by step. We see simple example, like imagine you are standing on a foggy mountain. You want to get to the bottom, but you cannot see it. So you feel the slope under your feet, take small step downhill, or keep moving until the ground becomes flat. That flat land is the lowest point to minimum loss. Gradient descent does the same to find the best M and C. In this slide, we see how gradient descent works. Then first start with random values for M and C, then calculate the gradient. This is the slope of the cost function. It tells us which direction is downhill and how steep it is. Like this done using partial derivatives from calculus. Third is update M and C. Then take a small step against the gradient downhill. First M new equal to M old is known as learning rate into gradient of M. Then C new equal to C old means learning rate into gradient of C. Then next step, fourth step is repeat step second and third many times until the loss stops decreasing. We have reached the bottom. Then key term is like rate alpha. This controls how big our steps are. Then there are two rate like too small and too large. In too small takes too long to reach the bottom, and too large we might overshoot the bottom and never find it. Then in our next slide, I mentioned real life application of best fit line and gradient descent. In this many fields and how it is used in that field is mentioned. In healthcare field, it is used like predicting patient recovery time from age and symptoms. Then in next finance, in finance it is used predicting stock prices or loan risk. Then next is marketing. In marketing, it is used like predicting sales from advertising spending, how the product is buying by. In this slide, we see real life application of best fit line and gradient descent. And there is various field and how it is used. We mention in field healthcare, linear regression is used to predict how long a patient will take to recover based on age and symptoms. This helps doctors plan treatment and explain recovery expectation to patient and family. The next is finance. In finance, banks and investors use regression to predict stock prices, interest rates, or loan repayment risk. This helps in making suffer investment decisions and reducing financial loss. Then next is marketing. In marketing, the predicting sales from advertising. Like companies use regression to predict sales based on advertising spending. This helps decide how much money to spend on promotion to increase profit effectively. Next is weather forecasting. In this that analyze past climate data to predict future temperature and weather condition. Like this helps warn people in advance about storms, heat waves, or heavy rainfall. Then next is agriculture. This agriculture is used for farmers mainly, like farmers and agricultural scientists use regression to predict crop yield based on rainfall, soil moisture, and fertilizer use. This helps us in planning farming activities and improving production. The next slide, gradient descent example. Here is one example where during each step the line updates M and C. Then with every iteration, the line fits data better and better. And finally, it becomes the best fit line. Here, I will tell you some advantages I have not mentioned, but I am telling. Advantage is for this is simple and easy to understand. Then fast to compute. Then works on small or large data, and ca- helps in prediction also. Then next slide we see in this here is conclusion. First, the linear regression shows the relationship between two variables. By first, this formula is there y equal to mx plus c to model that. Then next, loss function shows how wrong our line is. The best fit line is the line that minimizes the prediction error. The next is gradient descent helps minimize the loss. In this, the loss function m is e tells us how wrong the line is. Then last is by reducing loss, we find the best fit line for our data. Is like a gradient descent reduces the loss step by step and help us find the best fit line. There, the gradient descent is a key optimization method in machine learning also. Thank you.